Today we will now learn how to run an ARDL approach to co-integration using eViews, and I will show this procedure using general to specific procedure. In other words, we will now run ARDL general to specific model. For this I have got this data, and these are LE cons, LE price, LG price, L income, LN auto, LN oist, and I have these variables in level, so these are all in logarithm. Now I will open them in group. Before I open them, I should do something here. I think I will have to change the name here. I think I did something wrong here. I forgot to change the name, so I'll change it to LNest. That's better, I think, and I'll explain what these variables are in a few minutes time. Alright, so I highlighted all my 6 variables and I'll open them as group. Now let's have a look what they are. Basically these are my timeline dates, monthly data from 1997 month 10 to March of 2012. Now this variable is the consumption of e-fuel or e-commodity, I would say. So this is some sort of e-commodity, or in our day-to-day language it's a fuel that we will usually use for driving cars. So this is the e-fuel consumption variable. This one is the e-fuel's price, so that's e price, and this variable is the price of G fuel, so it's an alternative fuel to e-fuel, and this variable is the income of population, or I would say general income of income level of public in a country. And El Nauto is the number of automobiles which are run on an alternative fuel, not on e fuel. And El Nest is number of e-fuel stations where you can buy e-fuel, basically. Now L means logarithm in our case, so everything is in log form, basically. Now before we run this test, I would suggest you to check for unit roots, and well, ARDL approach is flexible, so you can run you can use I0 and I1 variables as well, but I'm sort of cautious about I2 variables. In some papers the authors claim that ARDL can be run using I2 variables as well, in other words integrated of order 2 variables, which requires the differencing twice, but that mightn't be true. However, to be on a safe side, it's better to take I0 and I1 variables for this model. So I assume that these variables are all I1. Now you could draw a graph of that as well to see well, you don't have the data, but your data can be graphed and seen if there is a trending, if the data doesn't fluctuate around a fixed mean, then that data will probably have the unit root, not stationary, basically. So I assume these variables are I1. Now I will close this group. Yes. What I will do now, since I'm running ARDL approach to co-integration, the first thing I have to do is to test if there is a long-run relationship among these variables. So how to do this? I will go to quick estimate equation. Now here is my OLS, or estimation equation estimation menu, and I will run OLS in a method, basically, for my ARDL model. As usual, I have prepared my model in advance. I'll copy it and I'll paste it here. Right, so this is my model, this is my ARDL model basically. Now this is the difference of e-fuel consumption, L econs. Now this is the first leg of that consumption variable. This is this first leg of E price, second variable. This is the first leg of G price, so on and so forth. 6 variables are here. All 6 variables are first legged here. Then the difference of the first leg of for all 6 variables here. Now this is the ARDL approach. ARDL model 111. In other words, ARDL in brackets 1111. You would see usually on the papers. Now I'll press OK to estimate. Well, unmatched parentheses it says, so I'll press OK and see what might have caused that error here. So let's see what I have done incorrectly. So I have okay, I see. I need to put another bracket here. Okay, done now, hopefully. Yes. Now it has estimated me my ARDL model. Right, so what I need to find is to see if these variables are jointly significant. And to do that, I will do a wall test and take the F statistic from there and compare it against the values provided by Pesaran et al. 2001. These values are bounds testing values. I will show you in a minute's time. So what I do is I need to find first the sequence of these what they call this level lagged variables. These are my difference lagged variables, so we will ignore them at the moment because they are not significant at the moment for us, or these are not important for us. So first important things are these. So what we do is I'll go to view and representation. I will have now the coefficient reparameterization. Right, C1, C2, C3, I need C4, and I need C5, I need C6. So first 6 variables are lagged level variables, and I want them to copy it into wall test menu. So I'll go to coefficient test, I'll go to wall coefficient restrictions, and here I will enter each variable. Now I have actually made it already. I think I prepared it already. I'm gonna put it somewhere here. I'm gonna do this quickly. I'll copy. Right, I found them. Copy and paste. So these are my 5 variables here, but I have 6 as far as I remember. So C6 equal to 0, 2. So I want to see if they are jointly equal to 0. These variables or not. I'll click OK, and null hypothesis is they are equal to 0 jointly, but my alternative hypothesis is they are not equal to 0 jointly. Okay, so we reject the null hypothesis and we find that they are not actually equal to 0 jointly. So this is the value we will take now. F statistic 3.99, or let's say 3. It's actually 4. So I'll memorize this now. That's 3.99. I'll go to the critical values provided by Pesaran et al. Now, since we have included an intercept, which I forgot to tell you about, let me double check if I did really include the intercept. No, I didn't. I was going to do so, sorry. So this is our ARDL model again. I do apologize for that. I'll include constant to see if and I will remove it if this constant is not significant. Let's click OK again. Alright, constant comes as significant value here, so I will keep it in the model. Now let me estimate the trend as well. I forgot to do that in the beginning, so I'll put a trend variable here, and I'll see. Okay, I could have the trend as well. That looks like it's significant at 5%. Now I'll go back and then do my volt test again, and I remember what they were. They were first 6 variables, so I'll continue that again. Equal to 0. Oops, what I did here is okay. Alright, again it's 5.09 and significant, so that's it higher. I mean, it increased the value actually. 5.09. So let's go back now. Now if you remember, I included intercept and trend. So now not this table, because this table gives you critical values when you have intercept but no trend, but I have trend. So this is the variable here, intercept and trend. Now I have 5 regressors, so I had 6 level variables which included the dependent variable as well, but I will remove the dependent from the system, and then I will have only 5 variables. So 5 variables, I want to test them at 5% significant levels or 95% level, and my 5.09 is higher than upper bound, so it's beyond this bound basically. I want. So in other words, that indicates that I have, in other words, my data has co-integration, or my data or my variables move together in the long run, so they have long run associations. In that case, I can estimate the ARDL model. So I'll go back and then estimate it. Now I will keep everything as they are, and I will click OK. And again, this is the ARDL model. It's the same model as we estimated earlier. I will not change anything. Now next step is to apply a general to specific method, or general to specific procedure, which says remove the non-significant variables or coefficients. Now if you look at the probability values here, the highest non-significant value is this one, so I will remove LG price E. So I'll go there, estimate, and I remove LG price E. Right, done, and I'll estimate it again, and I will see the next highest probability, this one, LE cons first difference, so DLE cons, this is the one, DLE cons, remove that. Okay, now what I have is this one now, DLE price, that's also the first difference, DLE price, done. Okay, now I have next one, L nest, number of E fuel stations, estimate the L nest, isn't it? Yeah. Oh, sorry, L nest itself, not the L nest. I shouldn't make a mistake. So okay, now I have my values, many of them become significant now, I can see. Now DL income this time. Okay, alright, so significant 10%, I can leave that. LE price can be removed. Right, done. Okay, done. Now I should say something here. Should have told it earlier. This value has to be negative and significant. Otherwise, you do not have any proper ARDL model, or you don't have co-integration basically. So this has to be negative. It's like an error correction variable here. It's an ECM term for us. Now I've got these results now. All I need is these variables now, all the coefficients, and I will copy them and paste them into my Excel. Now these are the long run coefficients, but I want to see long run effects, equilibrium effects. So I will copy them, okay, and I will open an Excel, okay, workbook, and here we go. Now I'll paste them here, paste. Okay, these what they are. So now what I will do, I will copy them again, I will basically transpose it. I make it look like equation. Right, so now what I will do is I will now normalize this equation by LE cons, or in other words, I will normalize it on LE cons. It's more specific, I think. So at the moment, can live with it. So at the moment, what we need to do is we will divide these coefficient values by minus LE cons to get elasticities. Now, what we do the first here equal LE income divided by minus, as I said, this value. Now, since I'm dividing this everything, in other words, all the explanatory variable, all the independent variables by explanatory variable, so I'll fix it F4. So I fix it, I put dollar signs, in other words, to fix it so it will stay there a constant value, and I will drag across there. Now here we go, these are the long run effects now, and you can basically, what you can do is you can interpret this as you do in a normal case, like 1% change in LE cons, 1% change in L income will cause 17.39% change in or increase in LE cons. So that's normal sort of interpretation when you use the log values. Now here we go, when there is an increase in number of alternative fuel using autos, there will be a decrease in e-fuel consumption, so that's negative. Similarly, that's interesting, when there is a 1% change in number of e-fuel stations, the consumption actually declines by 1.16 or 1.17%. So basically this is the result. So now, interestingly, these are significant questions, but we don't know whether these are significant. But some papers recommend or endorse that we calculate bootstrapped confidence intervals for these values, but I will come back to you, or I'll make another video on that later. So for now, this is the coefficients or effects, long run effects of our ARDL model. Now normally these values, usually long run effects, these values are short run effects. So these are in the short run and these are in the long run. I should say there is no long run effect on LA nest because there is no variable here, LA nest long run level variable. So in fact there is no association between them in the long run, so it's actually not significant, so we delete it. So this is the most parsimonious model we have made out of our data. So this is the sort of core model, in other words. So you could say I had what did I have? Price of alternative fuel disappeared. In other words, there is no long run relationship, apparently not significant, so I deleted them as well. However, this is the true model at the moment, or best model, parsimonious model for our study, or in other words, for our to see whether consumption increases or not. I should say I did some mistake. This is a consumption. So earlier I said I think price. So in other words, if there are more e-commodity or e-fuel stations, the consumption declines by 1.16%, not the price. Sorry, I think I misinterpreted earlier. The same here. The more automobiles of alternative fuel adapted, the more alternative automobiles of alternative fuel that consume alternative fuel, the less the consumption of e-fuel. That's actually an interesting finding. And the more the price of, the higher the price of G fuel, then the higher the price of the more we consume apparently, or the more that people consume apparently e-commodity. So that's actually an interesting find as well. Now this is a long run coefficient effects, these are the short run coefficients. So that's it for now. If I made a mistake due to brain malfunctioning during this video, hopefully you will leave comments and I will then correct them in my next video, or I will delete this video and replace it with another one. Alright, thank you, and leave comment please. Now I will stop recording.